In this experiment we're going to look at refraction of light in an acrylic block. I've already drawn around the block and marked off a normal and angles of incidence which increase in increments of 15 degrees. So you can see I've left the protractor in place. If I take it out of the way, you can see I've drawn a line at normal to where I'm going to place the block. It's a line at 90 degrees to the surface. I've measured angles of 15, 30, 45, 60 and 75 degrees and marked in where I'm going to send the rays. So all it leaves is for me to put the block carefully in place, and I've got to make sure that when I put the block in place that the line that I drew down to represent the boundary between the acrylic block and the air is exactly in place. We refer to the air as one medium and the acrylic plastic as another medium. I've set up my ray box so it's on 12 volts and I've put a single slit in front of it so that I get a narrow ray. So the first one I might do is I'll send it down the normal. So let's see that it lines up with my dashed line. I can actually see in the glass block and see that it's travelling straight down the normal. Now I'm going to mark where the ray emerges with two little crosses. I'm going to put 0 and a 0 there to represent an angle of incidence of 0 degrees. I'm now going to move the ray box so that I can get an angle of incidence of 15 degrees. Remember, if you're doing the experiment, that the ray box gets quite hot, so be careful how you touch it. Don't touch near where the lamp is. You can actually probably see that there's a partial reflection as well. So I can see where the ray goes. I'm going to mark where the ray emerges. I'm going to label this one as X15 and in the middle X15. I'll do the same for 30 degrees. That's the emerging ray, X30, middle 30, move it to 45 degrees. And you can see inside the block that the ray is bending towards the normal. And what you might be able to see looking at it, the ray, incident ray, the refracted ray, which is then incident on the second surface, and this emerging ray, the emerging ray and the incident ray look parallel. Till we take some measurements we won't know. X45, X45. Again, it's important to get this as precise as possible, because if it doesn't travel down the ray, the path that I've put on the paper, then all the measurements will not be correct. So this can take a little bit of time, and as you knock anything, that'll do. X60, X60. Then the final one, this can be hard because the camera's in the way. Having to take the ray box further and further back so I don't knock the camera out the way. Not so sure how good this will be. It seems to be almost coming off at the edge of the block. So that's not necessarily going to be a very reliable answer. Okay, so like when you're doing the reflection experiments, turn the ray box off straight away because it's going to be hot. I can now remove my block and I can complete the path of the rays when they're left by joining up these centres of these crosses. So draw that one to the block, put an arrow head on to show which way it was going. 15-degree one, angle of incidence of 15, up to the block, and I'm just going to draw in all of the rays. To say this one may well well, it indicates that it did hit the edge of the block there. That's why I started sending the rays in, not in the middle of the block, but to one side. If I'd sent it in the middle, they may have hit the wall, the boundary there. Now, what they do inside the block, I just have to, we know light travels in straight lines, so I just have to join them up. Oops, that one wasn't joined very well. Let's try again. I should really rub it out. Next one. I'll just pause at this minute. Now I've completed all paths of the rays. What I'm going to do is draw a normal where the rays leave the block. So a normal's a line at 90 degrees. So the first one that I put in place, well, actually that is still a normal. The next one, put my protractor in place. Right, with the protractor in place, 0 on where the ray is, I'm going to mark 90 degrees. I'm going to do that for the other ones and draw all the normals in. As you can see now, I've marked in all the normals for all of those rays. Now all I need to do is measure the angles of refraction when it goes from air to acrylic, the angle of incidence when it hits the acrylic to air interface, and the corresponding angles of refraction. So I'm going to put a protractor on, measure a couple of them, and then just speed the process up. So I'll do the first one, placing the protractor on there. In fact, it might be, it is still easy like this for me, lining it up. It's lined up and I'm measuring that angle in there. That's 10 degrees. So that one is 10 degrees. I'll do a little table on the side. I'm going to measure the angle of incidence when it leaves, and that is 10 degrees too. So that one was 10 degrees. And I'll measure the angle of refraction as it leaves. Just line the protractor up, and that is 5, 10, 15 degrees. Right, I'll just pause while I write in all the other angles. Right, because it's going to be a little bit complicated, it's probably easier to fill them in as we go along. So the first one where it was 0 degrees, that's down the normal, that's down the normal, so it's 0. Then when we had 15 degrees, angle of incidence was 15, the angle of refraction inside the acrylic was 10 degrees. As it was leaving the acrylic, 10 degrees angle of incidence and 15 degrees angle of refraction. Now to measure the other angles, placing it in here. I'm going to do all of them in one go, all the angles of refraction, just by measuring. 15, 30, 45, 60, 75. Reading off here, I can see that that one is 10, 20 degrees. The one there is approximately 28 degrees. The 60-degree angle of incidence is coming out as, oh, keep hitting it, 10, 20, 30, 35, 36, 37 degrees. And the final one is coming out as 10, 20, 30, 40, about 41 degrees. I'm going to place it on the other side and measure the angles this way, and I can see that that's 20. I'm going to pause it while I just measure the other angles as I go along. Right, I've placed the protractor on each of these angles and marked them. So this one, well, that was 20, that was 30. That one turned out to be 44, somewhere between 44 and 45. This one, 59 degrees, which is approximately 60. And this one turned out to be 75 degrees.